Hi, everyone. Thanks for joining our webinar today, Getting to AI ROI, Finding Value in Your Unstructured Content. We're just going to give a few more minutes for folks to join. So if you just be patient, we'll be starting in just a moment. Thanks. Welcome to today's webinar, Get into AI ROI, Finding Value in Your Unstructured Content. Our speakers today are Jason Bloomberg from market research firm Intellyx and Tom Wilde from AI platform provider Indico. Just some quick housekeeping notes before we get started. Both the recording and the slides will be available in email to all registrants following today's webinar. We will also be accepting questions throughout the webinar. Please submit your questions through the GoToWebinar question bar. And we'll also address those questions following the presentations. Thanks again for joining us today. Our first speaker will be Jason Bloomberg. Jason, over to you. Jason?
Sorry about that. Yeah, this is Jason Bloomberg, president of Intellyx, industry analyst firm focused on agile digital transformation. We also publish the Agile Digital Transformation Roadmap poster, and I'll have more information about that at the end of my talk here. So in terms of artificial intelligence, AI, the big picture, especially in terms of the enterprise or business context, the primary consideration for artificial intelligence today is automation, right? How can we automate both individual tasks as well as roles? And this is just part of what people do and helping people with their jobs by supporting what they do or augmenting what they do with artificial intelligence? Or are we actually automating the whole role, thus displacing a person? And this is one of the things we'll talk about. So there's also artificial intelligence or AI for business insights. Can we take massive quantities of data, run them through our AI engines, and distill key insights for the business that we may have not been able to determine without the role of AI? And then there's also the role of AI that AI might play in simulating human behavior. And this image here is of Sophia, a robot that is supposedly driven by AI. In reality, it was really more of a PR stunt with scripted interactions, but it still indicates the idea of simulating human behavior. If you sort of step away from the PR stunt and get into the reality of this, it's more about virtual assistants or chatbots. So we're all familiar with, say, Alexa or the Google AI interaction. These are both for consumer use as well as increasingly in the business as well, whether it's voice interaction or text-based interaction. That's the nature of a chatbot. So the key technology here is natural language processing, which is a key subset of the AI story. So when you talk about AI, you may be talking about a variety of different things. We might be talking about machine learning, which is more about taking large quantities of data and learning from that and distilling, getting to answers to particular questions, or it may be more about the automation or the human behavior, which depends upon natural language processing. So if we look at the overall market for artificial intelligence, these two charts, if you notice the horizontal axis, that covers about 20 years. And for the large part of that, the 1990s, there was investment in AI startups and startups developing AI systems, but a relatively minimal amount. Now, AI actually dates from before this, right? These charts begin in the early 90s. AI dates from the 1970s and 80s. There was a flurry of innovation, and there were, a lot of research put into AI. And then we entered a period we call the AI winter, where innovation tapered off, investment as a result tapered off. And really what was happening during the AI winter is that the technology wasn't up to the task, right? We didn't have fast enough processors. We couldn't store enough data, right? The networks were too slow. Just all of the different technology elements weren't yet in place. So really what these charts indicate is, as the technology improved, right, networks got faster, storage got bigger, processors could deal with more processing, it became more practical to now apply a lot of the research that had really been around since the 1980s. So it was, in the 1990s, it was already 10 years old. As we go into the 2000s, it gradually ramped up and then really started taking off in the 2010s with the technology that we have today, with GPUs, the graphics processing units that are even faster than our typical CPU, as well as the massive big data technologies that we have today. So as a result, we have quite a lot of interest in terms of startups leveraging a lot of these technologies to build a variety of different solutions. So in terms, this chart now focuses on AI, or these three charts focus on the skills that are required. And these actually come, the first two from Indeed and the third from Monster. So data based upon job search websites. And so what you'll notice here, first of all, the horizontal scale is really only starting in 2013 or the last one, 2015. So it's not the 20 years from before. We're really looking at just the last few years. And the share of jobs requiring AI skills has been going up rather linearly. So it continues to increase substantially in terms of share of U.S. jobs requiring AI skills. So if we compare that to other countries, right, so the blue line on the first chart corresponds to the blue line on the second one, you'll notice that UK is even more advanced, and then Canada is blowing both UK and US out of the water. So and this is happening in Europe as well. So there's a really global interest in artificial intelligence. So the monster.com chart in the lower right breaks down the different types of AI. So you see machine learning is the one that requires the most skills. That is perhaps the most basic part of the AI story, but also the most prevalent, the most advanced part in terms of deployments. But we also see deep learning. That's the technology behind, say, image recognition, which is a critical part, say, of autonomous vehicles. So that is quite advancing quickly as well. NLP, that's the natural language processing we talked about in terms of behavior, the chatbots and the virtual assistants and processing natural language in other contexts. Speech recognition as well are also seeing upticks in skills requirements across businesses. So now this chart is different from the other ones in that it's forward-looking, right? You'll notice that even though it starts in 2016, there's little asterisks by the years. These were all prediction numbers by this particular analyst firm. And it's always a bit of a black art predicting the growth of any market, especially an emerging market like AI. So it's really a bit of hand-waving, and really what this firm was looking at is a smooth curve, growth curve. In reality, growth curves are never smooth. There's always, bumps and dips, but it's a little hard to predict those. And then also notice what this chart is actually reflecting. It's revenues from AI for enterprise applications worldwide during this 10-year period. So this is focusing on enterprise applications alone, but that's really only going to be a part of the overall AI story, right? Because there are consumer applications and other types of applications like autonomous vehicles that may or may not be included in this enterprise category, depending upon the context. So whether or not it's actually going to grow this way, and by 2025 as well, whether or not AI is going to be distinct or simply a feature of all the software that we have, and then it'll no longer be a separate bar on a chart like this. It's just going to be part of how we build software. And that, from my perspective, that's more likely, right? That we're going to have an AI market that's going to grow, and over time, essentially AI is going to be part of everything that we do, and it will no longer be a distinct market in that sense anymore. And that'll probably take 5 to 10 years. So, but AI, even though everything is rosy, all the curves are going up and to the right, so everything is on the plus side, there's still some challenges. One of the challenges AI faces is simply bad PR, right? That people think about the dangers of AI run amok, right? Are we going to develop killer robots? What about Skynet from the Terminator movies, or HAL from 2001: A Space Odyssey? And even though the reality is that such technologies are well beyond our abilities today, right? We just have no idea how to build HAL. It's ironic that the movie says 2001 and here it is 2018. We still have no idea how to build HAL, right? And it's not likely we're going to in the near future. So this is really just a matter of perception, but the perception, nevertheless, is still driving bad PR for AI generally. A more realistic concern is the question of stalled innovation. I talked about the AI winter, which was really like the late 80s, early 90s, where innovation stalled and we sort of waited around for technology to catch up. If we look at what's going on now, we're talking about approaches like machine learning, deep learning, neural networks, natural language processing, and a few others. That's the same list we've had for 20 years, right? It's not like we've added a lot to the story other than more horsepower, right? We can get more value from AI in large part because we have better technology, but we haven't really made any disruptive innovations recently. So the question now is, well, when will we make further disruptive innovations, or are we entering another AI winter where innovation is going to peter off? And nobody really knows the question to that. My sense is that we will continue to have disruptive innovations, but it's been a little while since we had one, so it's one of the things that we just have to wait and see. Now, another real-world challenge are ethical issues, and the incident of that autonomous vehicle killing a pedestrian, that highlighted this very clearly. Right? Who was at fault for that? Was it the programmer? Was it the company who owned the car? If there was a person in the car who was responsible for grabbing the steering wheel and they didn't, or they did it improperly, is it that person's fault? And if you were to buy an autonomous vehicle that required some interaction from the driver, what is your responsibility to ensure that the vehicle behaves properly? And if it's a software bug, is it the driver's fault? Is it the company's fault? So these are questions we simply don't have established precedents for, right? We have to, as a society, figure out how we want to answer these questions. And so there's no obvious answer to any of these. So on the technical side, we also have data issues, right? The whole garbage in, garbage out problem. Machine learning in particular, we need to feed massive quantities of data to. It needs to be good data, right? We can't just feed it inaccurate information, out of date information, and we won't get good results. So ensuring that our data are accurate, that we have data veracity, that is, it truly represents the real world, is a real challenge. I mean, this is something that we don't really know how to do from a technology perspective. How do we ensure that the information we have accurately represents the real world? Well, we have to go out and look at the real world and see, right? But we don't have an automated way of doing that. So that's a key challenge. Data governance as well is a key part of this story, and compliance issues are now impacting this, right? With, say, for example, GDPR, we have to organizations around the world have to comply with these regulations, that can now impact the sort of information we can feed to our AI engines and the sort of conclusions that AI might give us. We don't want a situation where AI is able to essentially figure out something about an individual person that we shouldn't know because it's a personal information. So these are challenges as well for artificial intelligence that are more technical challenges. So where do we see AI actually being used in businesses today? Well, within the IT department is where a lot of AI adoption is currently taking place today. It's useful in cybersecurity for threat detection. Cybersecurity is a big data problem in many ways. You're going to be crunching a lot of information to identify and prevent threats. The problem here is that the attackers also use AI to mount threats. And if you look at some of the phishing attacks, it used to be, it's very obvious. You get an email and it was obvious it was a fake email, and they're getting harder and harder to detect. That may very well be because the hacker is using AI to craft better phishing attacks. So it's a cat and mouse game, AI versus AI, and that is becoming an increasingly important part of the cybersecurity story. On the operations side, AI is a key part of what some people call AI ops or AI-driven IT operations management, where operational information, log data, and metrics as well, that in order to determine root causes of events and hopefully predict problems before they occur. And then AI can also be used for automating tasks within both operations as well as across the IT department. And then IT can also provide what we call next best action recommendations. And this is how IT can actually help, say, a software developer or a person to say, putting together a workflow. So you're building a workflow, AI can suggest the next step based upon how, hundreds or thousands of other people have built workflows. So it can actually assist people in creating software as well as automating the management of that software. Outside of IT, AI is gaining traction in many different areas. In terms of individual vertical industries, if you have a vertical industry that has big data problems, we just lost our. Okay, well, I will continue. There we are. Okay, very good. If we have a vertical industry that is has a big data problem, say oil and gas, they're doing oil drilling, they're dealing with seismographic information. If you have large quantities of data and you want to glean important insights, then AI is typically the technology of choice for doing that. So that's an example. Wear and maintenance analysis in heavy industry, this is becoming increasingly important for any industry who needs to essentially maintain equipment. So it could be anything from a vehicle to a jet engine to a piece of factory equipment, right? You want to service it so that it doesn't break, right? If it breaks, you have downtime. That can be a money-losing event, or in the case of a jet engine, it could be a catastrophic event. So you want to avoid that. But the last thing you want is to have too much maintenance, right? Because if you do maintenance too early, then you're wasting money, right? You want to have maintenance scheduled at the right time, and AI is a technology that can determine that right balance between too much maintenance and too little maintenance. So if we look on the right side of the chart here, we have marketing. In the marketing world is also a very data-heavy, data-driven world. If you think about, especially about consumer marketing, where we're dealing with lots of information. So AI has actually for several years been a part of the purchase recommendations technology. So if you go to Amazon and they say other people who bought what you bought also buy these things, that is an AI-driven thing. Netflix has been doing that for years as well. So if Amazon and Netflix are doing it, then every consumer company is doing it at some point. So you can use AI to analyze large quantities of information of various feeds. So it could be social media analysis or dealing with, say, ad buying, whether it's traditional ad buying on television, radio, or on websites. These are all AI driven at this point. So in the finance world, automated trading, they're looking for anything that can give them an edge. So AI is obviously a key part of the automated trading world. And then customer service. We talked about virtual assistants, and increasingly the dreaded IVR, interactive voice assistants, press 1 for sales, that everybody hates. Well, that's now becoming increasingly AI driven, which hopefully will improve the customer experience. And it is getting better to some extent, and it will continue to improve. So these are just some areas. Really, AI is becoming useful across the board, but these are some key areas that are getting a lot of traction. So AI, though, isn't easy, and there's a number of reasons. First of all, if you look under the covers, there's a lot of very complex mathematics involved. So it's a very esoteric, a lot of theory. It's a very technical area, and there aren't enough people that really understand this. So if you want to get into a good career and you're technically minded, mathematically minded, AI is a good career because there's a huge demand for these people, and the experienced people are commanding crazy salaries today. So that is definitely a key part of this supply and demand equation. So there's also the good data problem I mentioned. Good data are hard to find. Large quantities of data are easy to find these days, but ensuring that it's accurate, that it represents the information that you're looking to deal with, that can be much more of a challenge. And machine learning can easily steer you astray if you provide it with the wrong information. It can lead you astray in ways that you don't expect. So that can lead to business challenges. And then there's also this broader story of context. And this is really the challenge with the whether it's HAL or Skynet on the evil side, but even on the good side, if you think about a general purpose AI, so AI that can carry on a normal conversation with a human about any topic. Well, we can't do that. We don't have that technology. We can only carry on conversations within specific topics, but if the human veers from the script, the AI is unable to keep up. So this general purpose AI, we just don't know how to do it. Maybe this will be the breakthrough that we're looking for. But for today, we're constrained by context. So we can process our operational information and glean insights about root causes of operational problems. But that technology is not going to help us deal with customer service, or we could deal with customer service, but that technology is not going to help us drive our car, right? Or we get, the list goes on and on. We have AI for particular tasks, but this general purpose AI, the conversational AI that we see from the movies, we just don't have anything that we see in the movies. So it's very different from that Hollywood vision of where AI is supposed to be. So some key takeaways from my talk. Even though this vision of general purpose AI, whether it's commander data from Star Trek: The Next Generation or the evil robots of the future, we're not anywhere near any of those, but nevertheless, AI is providing real value today. It's not just hype, it's real technology that's solving real value, and it's being incorporated in many different enterprise technology, software technologies across the board. It's now quite broad-based in terms of its adoption. Furthermore, it is a key to competitiveness for many organizations. AI can be the key to distilling the business insight that is necessary to be competitive. So if you're not doing it and your competition is, that puts you at a competitive disadvantage. And once you get into this situation where only some players have it, but they get a competitive advantage, then very quickly everybody realizes they need it. And we're sort of at that point now. So there's sort of this rush from on the business side to have AI supported decision making, because without it they're at a competitive disadvantage. So forget the robots of the future, forget the Hollywood vision of artificial intelligence, focus on the real business value that software can deliver today and how it can improve your competitive positioning, so it becomes now a competitive priority for your organization, decision making and other capabilities that AI can provide. So that's a bit for me. So there's my email address and the EBIS Wizard and my Twitter handle. If you want a copy of the poster, go to agiledigitaltransformation.com. And with that, I will turn it over to Tom.
Okay, excellent. Thank you so much, Jason. And Jason did a great job of describing why there's so much interest in AI, what's driving that from a market perspective. I'm going to work through unpacking what is AI and what are some good applications. How do you think about the ROI around AI? Because I think in our in our experience with customers, typically that's something that is very challenging at the outset. How do you dimension an investment in AI in a way that all the stakeholders in the company can get their head around? A little background on me just for a second. I've been in the enterprise search space for 25 years, and search has really been the original killer app for dealing with unstructured content, which I'm going to touch on quite a bit here. So unstructured content is all the things that live outside of databases and spreadsheets. These are documents and contracts and text messages and chatbot logs, all this unstructured content. About 80% of an enterprise's content is in unstructured category. And AI really represents a paradigm shift in how to deal with unstructured content. We're no longer tethered just to the notion of keywords, which has really been the search paradigm for so long. And I'll get into some detail on what that means and how to attack that problem. But first, maybe a brief history of AI. So surprising to some, but AI is actually not a very new concept. AI first appeared in the 50s and 60s, and the concept of AI stirred a lot of excitement, and as Jason pointed out with HAL and some of these other sort of Hollywood manifestations of it, were born out of these scientific discoveries that indeed computers could be taught to think this way. The big challenges at that time revolved around data access and compute power primarily. Fast forward into the 90s and 2000s, machine learning really begins to flourish at that time. Think of the initial machine learning as being very capable at doing large-scale counting tasks, statistical regressions, those kinds of things. And that really took off in the 1990s into the early 2010s. What we've seen in the last 5 years is an explosion of a subset of artificial intelligence called deep learning, which is actually a subset of machine learning even. And deep learning is based on neural networks, and it loosely attempts to mimic the way the human brain thinks about problems that it's presented with. And I say loosely because it's a very crude imitation of the human brain. But that's where all this massive interest has come from, that in the last 5 years, we've started to see an explosion in applications around things like image analysis, speech to text, document analysis, driven by primarily deep learning as being what's really exciting. But of course, we're following on sort of Jason's story arc there. We really are at the peak of the hype cycle here, if you think about it in terms of the way Gartner presents it, which is we're at the peak of inflated expectations. And I think that's why, as part of Jason's presentation there, there's the sort of cautionary tales that we need to be realistic and patient with applying these technologies to solve some fairly practical problems today, even though some of them are quite exciting, or risk falling into the trough of disillusionment where our actual experience with the technology underwhelms. And there's certainly signs that that's taking place today a bit. I know that when I talk to customers, very frequently the first few conversations, we have to adjust expectations and what makes a good use case. So that's a key focus here that I'm going to spend on the conversation here. What you can see here is the conventional wisdom is that, as follows the hype cycle here, as we have to deal with some of the realities, whether it's from Forrester or Gartner or MIT studies, very few companies have actually adopted AI in a meaningful way yet. This study showed 5% have actively adopted it, and probably only about 1/10 of those folks have actually been able to point to a real ROI. And that's why we crafted this topic for this webinar, because we found that people were struggling thinking about ROIs that related to implementing AI. So that's what we're going to get into here. So let's talk about unstructured content for a second, because it's so prevalent within the enterprise, but has largely been untouched by a lot of the advancements in traditional machine learning in terms of machine learning's ability to do large-scale complex counting tasks. That's difficult to do with unstructured for the very reason that it is unstructured and therefore lives outside of these applications where sort of statistical analysis is possible, databases and spreadsheets and things like that. And what we find is that inside the enterprise, most unstructured content falls into some form of manual process, where documents and text is being handed from person to person to be reviewed, annotated, evaluated. This is true in the legal industry. This is true in the mortgage industry. This is true in the insurance industry. Anywhere where documents are very important to the task being accomplished. And of course, because they're so manual, oftentimes you have at a minimum inconsistencies and often outright errors. And when you actually codify these processes and analyze what's going on, you see just how inconsistent they are, despite the fact that this same manual process may have been in place at these companies for many years. And this results in both actual expense in the form of missed revenue, or on the compliance side could result in regulatory risk and leading to fines and things like that if these processes aren't closely followed, as more and more regulation has come into the market around the use of data and the way we can market to customers. The need to comply and make our processes compliant is really important. So how do we tackle some of these things and think about the ROI? Well, first, let's think about what's the big deal here. And a lot of times I get asked this: what is the big deal with AI, especially as it relates to deep learning and solving unstructured content problems? Well, the way I think of it is as follows. For the last several decades, we've all been taught that to make use of our unstructured content, we need to learn to speak to the machines in machine language. And if you think about the basic Boolean query, for those of you who are search savvy, the Boolean query is actually constructing a request for information in a way a machine can understand, right? So we say this and this, not this, as a means to try to help the machine sort through the content it has and give us back an answer. This could be in the form of a list of documents or hits on particular content. The problem is, if you're not good at expressing your interest in a way the machine understands, you don't get good results. So that's been what we've all lived with for the past several decades. Deep learning completely changes that around and literally inverts the equation here. So instead of me constructing my request to the machine, instead what I do now is simply give the machine examples of what I'm interested in. So I could give it a set of example documents and ask it to find more like that. That would be a comparison task. I could give it examples of extractions from documents and ask it to find more extractions like that. That's typically known as sort of named entity extraction or topic extraction. Or I may ask it to classify documents based on a set of documents I've already classified. So I just give it examples, and the beauty of deep learning is it figures out the equation that I actually intended and continues to use that equation to bring me back information that's going to be relevant to me. So I've literally inverted this model where finally the machine can simply observe what I'm doing and give me information that's going to be relevant to what I'm looking for. And in this sense, the right way to think about artificial intelligence for the most part is it's very good at mimicry. It's a very, very skilled and intelligent mimic. And so it's very important at the start of a project, you are able to give it the outcome you're trying to achieve. That's really the secret here to AI success, and I'll go into some of the building blocks that relate to that. So that's sort of the big deal. So let me break down some of the definitions that we've talked about here. At the very top, if you think about this as sort of a wedding cake, artificial intelligence is the all-encompassing concept here that all of this is built on. And artificial intelligence is basically a computer program that can automate a process that tries to approximate the way a human would think about it. And this is machine learning, deep learning, all these things that sit inside of this AI construct and is used to achieve things like self-driving cars and robotics and speech recognition and document analysis. Data science is actually the skill that sort of sits alongside this. And data science is having a huge moment, right? I think if you look on the job boards, as Jason pointed out, any company today of any scale is trying to solve this problem of being data driven and digital transformation by hiring these skill sets. The challenge is there just aren't enough people out there to fill all these spaces. So the technologies need to become more friendly to bring into the equation what's being referred to as the citizen data scientist. Point and click tools that don't require PhDs in machine learning or computational learning to be able to use these skills and take advantage of them, use these technologies and take advantage of them. Machine learning kind of sits inside AI as a field where teaching the machine to make decisions and determinations based on data. So as I pointed out earlier, you feed it data that has a certain set of attributes, and it can then begin to solve for other data you feed it based on observing those attributes. So you're not explicitly programming the machine, you are giving it examples and having it solve for what patterns it can find there. As I pointed out, the most recent innovation is deep learning, which is again another subset. This is a subset of machine learning. And unlike machine learning, which relies heavily on statistical regression type techniques, deep learning relies on something called neural networks. Neural networks are a series of nodes that attempt to, through trial and error, solve for an outcome that you've defined as being interesting to you. So you give it an outcome and you feed it inputs, and it iterates until it is able to come up with, in simple terms, an equation that solves the outcome given the inputs provided. This is somewhat how the human brain works, obviously on a vastly more complex and robust scale. So deep learning is extremely exciting on that basis. The challenge with deep learning, and we'll get into sort of the building blocks for AI here, the challenge with deep learning is the amount of training data required. So when you look at those inputs, what you need is not 1,000 inputs or 10,000 inputs. You often need 100,000 inputs or 1 million inputs of labeled examples before you can begin to build a robust deep learning algorithm. It needs that much data to create this equation it uses to solve for the output that you're desiring. Which leads us to our last definition, transfer learning. Transfer learning is an attempt to solve that training data problem. Most of us in our daily work lives don't have access to 10,000 or 100,000 or 1 million labeled examples of the problem we're trying to solve. At best, we might have access to 100 or 200 or even a dozen. So transfer learning attempts to solve that problem by allowing you to teach a machine a generic set of skills and then use that as a means to solve a specific set of problems that you provide for it. And the analogy I like to use is, if I gave a newborn baby these two pictures and I told the baby to pick out the tiger, even giving the baby hints that the tiger is the large cat with black stripes, the baby would fail at this. Yet if I tried the same test on a toddler, the toddler would pass this with flying colors. That's because the toddler has learned the way transfer learning works. When we teach our children, we attempt to give our children features that they're likely to encounter out in the world as a means to assemble those features to solve new problems that they see. In this case, we've taught the toddler cat, big, orange, black, stripe. Those are all features. They are then able to quickly assemble those to solve for tiger. So this is a way to handle the data training problem that exists with trying to use things like deep learning. So building blocks for success. Again, when we talk to customers who are interested in using AI because they've heard about the power of it and they've seen others have success with it, very typically they don't know where to start and what are the building blocks of AI success. So I wanted to walk through a few of those here with you today. The first, and by far the most important, is data. Data preparation is the single most important aspect of any machine learning task, and specifically labeled data. So you need to be able to provide the machine with data that represents an outcome that you've determined as being valuable and being valid, right? So this is your sort of gold standard data that the machine will use to base its algorithms on to create this mimicry that you hope it can deliver for you, or these insights that it can derive for you. So labeled training data, very valuable. Secondly, compute power is a little bit different with AI than it is in traditional computing. With deep learning specifically, deep learning requires a very, very large scale of computational capabilities. And those have arrived in the form of GPUs, graphic processing units, typically found in gaming consoles and things like that, but now found in boxes designed to deliver deep learning type applications. The good news is GPUs are now widely available within the public clouds, Amazon, Azure, Google, and so you can get instances of GPUs in these clouds with which to run deep learning type applications on. But deep learning specifically does require GPUs in order to perform the calculations that go into these use cases. This one's often missed, but expertise is a really critical component here, the SME. Too often we encounter projects where only the data scientist or the IT group is trying to solve this problem, thinking only about the data itself. And what's missing is the subject matter expertise or business line owner to be able to sort of observe, curate, and define success in business terms. What will be valuable for the business and how will we know we've achieved it? That has to be input that's derived from an SME who needs to be part of these projects. And oftentimes we see them being left out or too marginalized, and thus the project becomes too academic and disconnected from what the business is actually trying to achieve. And then finally, a hypothesis around ROI. If this project succeeds, what is it worth to us? And that will tell you how much you should be investing in time, money, and people. Oftentimes we see projects get kicked off where the ROI is sort of the last question that gets answered, and oftentimes too late in the process, where a lot of effort has gone into it and the project team at the end says, oh, we can't make a business case for this. The business case should be something you start with to know that if this investment is successful, it has a payoff that's worth something to the business. So forcing yourself to come up with a hypothesis around ROI, very critical for AI success. And when we think about the prime elements here, now drilling into unstructured content a bit more, what happens in a project is you now deconstruct that project or that problem statement down into its piece parts that deep learning or AI is particularly good at. And in the case of unstructured content, thinking about things like image analysis, text analysis, audio analysis, typically you have 4 key prime elements that make up any use case. Classification and regression. So I want to classify a certain set of things in a way that is valuable to me and that I can demonstrate with a small set of labeled data. Unsupervised discovery. I want to look at a large collection of data and find signals and patterns within that data that I can then use to build models to apply to future data that I might encounter. This is typically done with things like customer support analysis, chatbot logs, and things like that. Comparison. I have 2 things and I want to see how similar they are, and I want to do that on an automated basis. And maybe I want to do that at a very large scale. So given these 10,000 contracts, I want to score all of those contracts and see how closely they conform to my ideal contract language. That would be a good comparison task. And then search and extraction. I want to find data of this type within all of these documents, or I want to extract these objects from within all of these images, and so I can do something more with that data once I've extracted it. So these are examples of building blocks from a technical standpoint, or how you deconstruct a use case into sort of approaches that you can take for success. And from a use case perspective, you see things like process automation, so automated contract analysis, RFP analysis, risk and compliance processes. These are all ripe for automation and augmentation using AI-based approaches if you can use AI, of course, to understand the content in question. The second typically are things like content analytics, resume screening and comparison to job descriptions, classification, customer feedback, and sentiment analysis, emotion analysis. These are all great analytics use cases of deep learning and AI when you're dealing with unstructured content. So in summary, getting to AI ROI, a clear business problem with a defined outcome that is valuable to the business. Involvement of the subject matter expert. They're the ones who are going to determine success, define and determine success, evaluate success. And then finally, the ability to create labeled data that you can use for the training portion of an AI-driven project. You must be able to train the AI with the outcome that you're hoping to achieve. Without it, AI can't even begin to solve for the problem at hand. Great. Well, hopefully you found that useful and interesting. We would like to turn now to answering a set of questions. Again, if you have questions, feel free to drop those onto the question tab of the go-to panel there to the right, and we can take your questions. I see we've got the first few queued up there. So Tim, if you want to queue those up, we can tackle those.
Sure. Thanks, Tom, and thank you, Jason. Yeah, quite a few questions here. Let's see how many we can get to before we have to finish up. But just one, or quite a few still about, just want to confirm both the recording and the slides will be available to all registrants following today's webinar. So quite a few of you asked about that. Thank you. So Tom, here's one for you. Where will AI deliver the most ROI for businesses in the next few years? Will it be on sort of the customer-focused use cases like intelligent assistants and virtual customer service, or on the internally focused use cases like business process efficiency?
Yeah, I think it's hard to predict which one will deliver the most ROI. I think the key with all of them is to start with a well-defined, discrete problem, and I think you can find those within the customer-facing use cases you described, as well as internal processes and process automation, and analysis of things like customer support data to figure out how to improve the product, and those kind of tasks. But I think the key is be very diligent in identifying narrow use case, show some success, and then build out from there. Those are the building blocks to make it work. I think if you try to boil the ocean and try to make the AI solve too many things at once, you may find that people get disappointed and then disenchanted, and that would set you back in terms of bringing such technologies into your organization.
Okay, thanks. Jason, one for you. Will we ever reach a point where AI is able to write its own software?
Yeah, well, this is an interesting question because the question is, what does it mean? What would it mean for AI to write its own software? And Microsoft and Google have done some proofs of concept of this kind of thing. And what, for instance, Microsoft Deepcoder, which is really more of a research project than anything else, what it did is it used machine learning techniques, just like Tom was describing, to essentially assemble bits and pieces of human written code into a working program. So did the software write its own software? Well, in a way, but it was really assembling bits of human created code. So, if anything, it was plagiarizing more than writing its own software. And so, the question is rather, when will software, AI be able to write entirely new software? So can AI be creative in how it creates software, the way a human is creative when they create something that has never existed before, as opposed to assembling pieces that pre-exist? That's something that we don't really know how to do yet, but it wouldn't even be clear what it would mean. Is how do you tell that AI what you want from the software? And you have to provide sufficient detail. And isn't providing sufficient detail just another kind of programming, right? So what's happening then is that if you're able to provide a piece of AI sufficient detail so they can write a program for you, what you're really doing is relying upon the AI to help you write that program. And we're already seeing some progress there where AI, I mentioned next best action, for example, where AI can help a programmer with his or her programming tasks. And it's still rather rudimentary today, but you can obviously see that advancing where a human can express the intent for a piece of software and then work with the AI in order to create the software. And I think we're already on the road to that, and it's just going to get better in terms of the sorts of software and what kind of can provide.
So Tom, related to that, do you kind of foresee AI replacing people or sort of augmenting them, making them more effective?
Yeah, I'll tell you that the most common use case we hear is where customers are looking to increase the capacity of their existing resources, not replace people. I certainly think some jobs will be lost into the future, but I think new ones will be created and new roles will be expanded to reflect that. So I think that more than ever, we hear from customers who are really looking for more of a bionic arm. I think is a better analogy than a robot, because a robot suggests that it's going to replace people, and instead a bionic arm suggests I'm simply going to allow them to be able to lift more, right, in a warehouse, to use our physical analogy. And that's a good analogy for how I think AI is being thought of within, say, Fortune 500s that we talk to.
So there's a few questions I think for you that you can both weigh in on, and about sort of two parts. One is, how much has AI been overhyped, and related to that, what are some of the biggest misconceptions that you see and hear about AI when you talk to users?
Jason, you want to tackle that first?
Well, sure. Yeah, I mean, I talked about the overhyping in terms of expecting the general purpose AI, whether it's for Skynet or for Commander Data, right? Just that the idea of the intelligent robot, and that's still out of our reach, and so that's impacting the story a bit. But I think there's also just the general hype that about what today's AI can actually do, because AI is a hot term. Everybody wants it. Vendors are liberally sprinkling it in their marketing, and sometimes it's more sophisticated technology, sometimes it isn't. So you really have to look at what a particular vendor is actually doing. Just because they use the term AI, that doesn't necessarily mean that they're doing some of the more advanced stuff like the deep learning that Tom was talking about. Sometimes it's very rudimentary machine learning, which is a less advanced capability than some of these other technologies. So as with any emerging technology, you have to get beneath the hype and really look at what's really going on.
Yeah, and I think from my perspective, where I commonly see people struggle with is they want AI to solve what I call the unknown unknowns, right? So if this is our 2x2 matrix, the lower right corner might be the unknown unknowns, and AI is not really ready to do that. The known unknowns it's really good at, right? Because you can kind of give it a problem to solve where you have at least an inkling of what you're looking for. But I think what human intelligence is uniquely good at is solving for the unknown unknowns, and so that's where I see the stumbling blocks typically in companies. Is I tend to step them back a little bit and say, okay, let's solve something that has a defined business outcome and value to you, rather than go on a very large exploration, of the data or the content and hope that we find something. That's typically not a good way to get started, and would end in frustration. So that's where I see it most often.
Great. Well, thanks. I think we're just about out of time here. Again, we'll make the recording and the slides available to all the registrants. You'll be receiving an email with access to those. And I want to thank everyone again for joining us today. I hope you found it informative, and look forward to engaging with you in the future. Thanks very much. Have a great day.